Hey guys, so today we'll talk about the law of sines and more specifically how to prove it using some wet toes. So let's dive right in. SOHCAHTOA. So you literally have to soak a toe to understand what it means, but not really. SOHCAHTOA is a really cool mnemonic device which can help us remember the definitions of trigonometric functions in right triangles. So let's see what it means. Say we want to find out the angle, this angle alpha. And how can we find its value? So SOHCAHTOA is made up of three parts. The first is SO, and what it means is the sine of this angle alpha is equal to the O divided by H, the opposite over the hypotenuse. So SOH is sine is equal to opposite over hypotenuse. The second part, COT, is pretty similar, but its cosine of this angle is equal to adjacent over hypotenuse. So now it's not the opposite side, but the nearest side divided by the hypotenuse. And the third part, TOA, is the tangent of this angle is equal to opposite over adjacent. And that's pretty simple. Now, if we wanted to do this for the other angle, we'll call it beta, we would just flip the sides. So then this side would become opposite, this side would become adjacent, and the hypotenuse would obviously stay the same. So that's it. It's pretty simple. Now using this, let's now prove the law of sines. We start with a triangle. I mean, this one kind of looks equilateral, but it doesn't matter. And the first thing we do is we draw the height. So we draw a line from one of the angles that is perpendicular to the opposite side. And we know it's perpendicular because we can write this little square here, meaning that this angle is now 90 degrees. And as we said before, because this is the law of sines, we're obviously going to use the first part of SOHCAHTOA, the SO. We know that the sine of an angle is the opposite over hypotenuse. So let's just rewrite that. Now, let's start by calling this angle alpha, and by calling this line that we drew h, the height. And this hypotenuse of the two right triangles that we now have, we'll call it b. Now, we know that the sine of this angle alpha is equal to the opposite over the hypotenuse. So it's equal to h divided by b. Now, from this it follows that h equals b times sine of alpha. All right, great. Now let's go to the other side. We'll call this angle beta, and we'll call this hypotenuse A. And once again, we know that the sine of beta is equal to the opposite over the hypotenuse. So the sine of beta is equal to h divided by A. Okay. And now from this, it also follows that h equals A times sine beta. Okay, but now we also know that h is equal to h, which is pretty obvious. So that must mean that these two values must be equal to each other. So let's rewrite it. We can write A times sine beta equals B times sine alpha. And that's pretty much it. We almost have the proof. Now we can just rewrite it in one of two ways. We can either divide by the angle or divide by the length of the side, because usually in literature you'll see it both ways. So we can rewrite this as sine alpha divided by A equals sine beta divided by b, or we can write it as a divided by sine alpha equals b divided by sine beta. And that's it. There we have it. That's the proof of the law of sines, and it's as simple as soaking your toe. So now let's try to use what we just learned to try to solve an example with the law of sines. So we have a triangle here with random sides and angles, and let's say that this angle is 100 degrees, and it looks about right. It's just more than a right angle. Then the opposite side is 12 centimeters, and this adjacent side here is 8 centimeters. And we want to try to find this angle beta right here. So how can we do it? Let's rewrite the law of sines. We know that sine of alpha over A is equal to sine of beta over B, right? So in our case, it's sine of 100 divided by 12, because it's the opposite side, is equal to sine of beta over 8, because once again, it's the opposite side. To find out sine of 100, we need to plug it into a calculator, of course using degrees and not radians, and we know that it's about 0.985. So let's plug that back in. We have 0.985 divided by 12 equals to sine beta over 8. And if we rearrange the equation, we know that sine of beta equals to 8 times 0.985 divided by 12, which simplifies to about 0.66. So we know that the sine of this angle that we're looking for is equal to 0.66. Now to find out the actual angle, we need to take the inverse of the sine, or sometimes called the arc sine. So it would be beta equals inverse of the sine, we write it like this, or arc sine, is of 0.66 equals 41.3 degrees. And that's it, it's that simple. That's the angle that we were looking for. So I really hope you liked this video. Please click subscribe and look forward to seeing you in the future.